All right, my name is Mahul, and we're going to do Python basics. This is pretty advanced, so don't feel bad if you don't know everything here. But this is kind of leading up to what was helpful for me in terms of writing my Discord bot. Um, so what do computer programs do? Like that's the fundamental question, right? And programs, they work by manipulating values, and expressions in programs evaluate to these said values. And so what is an expression? Expression is like in algebra, 1 plus 2. So that's an expression which isn't fully evaluated yet. And so the value of the expression is 3. And so similar to the Python interpreter, evaluates expressions and displays their values. Um, so like 1 plus 2, this is our like, okay. So we go into our Python interpreter, and we have the expression 1 plus 2. It outputs the value 3, right? And so an expression describes a computation and evaluates the value. So all of these here, 20 plus 21, negative 2021, all of these expressions share one thing in common. And that thing is that we can abstract all of these expressions away to the function f of x, similar to like in algebra. Um, yeah. And so more on values, programs, essentially all programs, what they do is that they manipulate values in some way. And so values, what they look like, there's different types of data. There's different data types in Python. Um, and so we have integers, just like in math. We have floats, which are basically the numbers, but with decimal points. Strings are like words, but we put what do we call it? Like sorry. Yeah, so we have the string hello, and like to start a string, we use like quotation. We can have either single quote or double quote. CS61A is an example of another string. And we also have booleans, which are either true or false. Um, Fun fact about booleans is that true is the same as 1 and false is the same as 0. And we have like false types in Python, and the false types or the false values kind of are like the empty list, the empty dictionary, 0, like um, 0, is this true? Yeah, 0 equals false. Oh wait, okay, I guess that okay, but this is like still a false value, the empty dictionary. I'm trying to think of other ones. The empty string. Yeah, there's a lot of false values, but anything that isn't a falsy value is a truthy value. So every like integer other than 0 is a truthy value. So we could say this. I don't know if this is true. Okay, no, but yeah, true is the same as 1 essentially, but yeah, but this in terms of truthy values, I'm not going to get too into it. Um, yeah. So the other data types, so yeah, we have strings, integer, floats, we have the complex numbers, but that's not, we don't really care about that unless we're like coding something math related up. Sequences, we have like lists. I'll get more into this later. Tuples, like the range. Mapping, we have dictionaries with like a key value pair. Sets, we don't really work with sets, but sets are kind of like a list, except they're kind of denoted in like the brackets. And essentially it's like a collection of items, except we don't allow duplicates, and I believe they're unordered. The set, I believe, can be unordered. Booleans are like true or false. Binaries, we don't really work with binaries that much. um yeah, I'm not going to talk about that. So expressions and values. So expression hello evaluates to the value hello, like the string. So hello is already like simplified to its like to like the most simple. So just evaluating like the expression hello is just gonna return the value hello. But the expression we're saying we want to divide, we want 7 divided by 2. What is that? That isn't simplified enough. So we're gonna reduce this, and it's gonna evaluate to the value like the float 3.5. And so this one gets a bit more complicated, but we have the function add, which takes in the parameters 1. And then we have another function call with max of 2 and 3. And so what max does is you have like two parameters, like input 1 and input 2, and returns the number that's like the maximum of like input 1 and input 2. And so first what happens is we evaluate the operator, which is add, and then we evaluate the operands, which are kind of like the parameters of the arguments. So the operand is 1, and the next operand is max of 2 and 3. But we have to recursively kind of evaluate the operator again, because this is like a function call. And so we're going to evaluate the operator, and so we see that the operator is max, and we evaluate the operands, which are 2 and 3. And we're going to call this function, and it's going to return us the value 3. And so now what we would be left with is add 1 and 3. And so now that we like know what the parameters are, we can perform like the function add with the parameters 1 and 3, and that's going to return us the value 4. So call expressions. So we have the operator add and the operands 2 and 3. And so we say that we apply the operator to the operands. So apply the function add to the operands or the inputs 2 and 3. And that would return us the value 5. So operator and operands are also expressions, as we can see. So the evaluate values. So evaluation procedure. So how do we evaluate these call expressions? We first, what is that? We evaluate the operands from left to right. So we start with 2. Like can this be simplified further? Well, no, it's just like that's it. Like it's just 2. But like in the other example, we had to evaluate what max of 2 and 3 is, and that's our like kind of operand. But and then we look at 3, it's already reduced to like its simplest form. And then we apply the operator add, which is a function, to the operands or the arguments 2 and 3, and that would return us 5, right? And so more on functions. So add, like we saw, add is a function, max is a function. There's also a min function. But yeah, functions, they kind of allow us to abstract away entire expressions and sequences of computation. So functions, they take in some input that we saw, like add, add takes in a number, 2 numbers, and they're called arguments, or we can call them parameters. They're essentially the same thing. And so what we do with these parameters inside of this function, we want an output. And it's called the return value. And so how do we create functions in Python? We use the keyword def. And so their input is given in a function call, and their output is given by return statement. So we can do a demo. And 1 second. Okay. Now what we're gonna do is we're gonna do a live demo, and we're gonna code up a couple of functions. So I guess in like math, let's use our interpreter. So to square a number, what does that look like? So 5 times 5, right? Or 5 times 5, that's like the same as 5 squared. So like to multiply, we would use like the asterisk. And this is our expression about it evaluates the 25, the value 25. And similarly, if we use 2 asterisks, that means we're scoring, like we're doing 5. And then the next number right here is like the number that we're like, it's like what do you call it, an exponent. So 5 cubed is 125. 5 squared, which this is what we're going to kind of use, is 25. What is 6 squared? Well, we'll have to type in like this kind of expression that evaluates to 36. and 2 squared 4. Um, well, that's cool, but we could kind of abstract this away to kind of work with like any numbers. Like we could create a function that does this for us. Like of so we're gonna do that right now. We're gonna create our first function called square, and it's gonna take in an input n, which is gonna be an integer, and it's gonna return an integer. And so our operator, or like our function is called square, and our operands, like our arguments, is n. We're saying this is an integer, and we're gonna return, like a function always has to return something, and the value we want to return, we need to say what like I guess what we're really doing, that we saw like in our interpreter, is that we have the expression n squared, or n times n. I'm just gonna say n times n. Um, so that's what we're kind of applying. This is what we want to do, but every function needs to kind of return a value. And so the value that we're going to return with this function is n times n. And so that's what square is doing. And just to show you how this works, we're going to print square of 4. What does square of 4 return? It's going to, when we print something, it shows us the return value in our console. And so what happens is we create, we just, the function square is evaluated, and um, we open up our global frame, we set like the variable square to the function square, and now we're on this line, we're evaluating, okay, print square of 4. We're going to open up a new frame, and we're going to we have the parameter n, which is an integer 4. And so now we're gonna go into the body of the function, and we're gonna perform the computation inside the body. And it's saying we're gonna return the value of n times n. And so what is n times n? We're gonna return 16. And so we go back to the line, and we're gonna print, we've evaluated square of 4, which is 16. And so now we print 16 into our console, or a log. So that's an example of a function. Yeah, that's an example of defining a function. Going back, I think I might do another demo or later, but so a function takes in an input 5, and it outputs the return value 25. So this is kind of the template of how we would like define a function, and we have the name of the function in blue right there, and then we put the parameters. There can be more than one parameter. Like I guess in math, like you have like f of x equals like 3x plus 5 or something. So there's only like one input, which is like x, but I guess like in multivariable calculus, you actually have more than one input. But yeah, but in Python, yeah, you can have more than one input, or you can have 0 inputs too, like yeah, or like parameters. And so this is the body of the function, which is the we always, or we don't have to always return something, but usually we will. So we're going to say return whatever the expression we want to return is. So yeah, this is kind of what we just did right here. So we create the function square, returns x times x. So we're setting y equal to the expression of, which is we're going to call square with the parameter -2. And so I guess what this kind of looks like in Python tutor is just like y equals square of -2 would look something like this. And so we're like create the function square, and now we're going to say y equals square of -2. Well, what is square of -2? Like this is a function call, like a call expression. So we're going to evaluate what that is, and it's going to give us 4. And so now y is going to be set to 4 in our global frame. So that's what happens. So yeah, this is the function signature, which contains the name and the parameters, or the number of arguments in our function. The body of the function. So execution rule is we're going to first like create a function with the signature, and set the body of the function. So we always have to indent when we create like a def statement. Everything after the def statement needs to be indented. As you can see here, there's like an indent from here. Yeah. And what happens is like the name, like I guess right here, um, oh, I don't need this. We bind the name square to the function square. Like I guess the variable square is kind of a variable. And in our global frame, we bind the variable square to the function object, essentially. And so it's really important. So write clean code. I think this is the part of the slide when we describe functions. I think it's really important to know what the function is doing. So right here we have a doc string which describes the behavior of the function. So define square of x, right? And so we're gonna say what it does, and so it's gonna return x times x. I mean, this is a very like basic example, but when we're writing more complex code for like our bot and somebody else is kind of reading our code, um, like it wouldn't be like super clear to them as to what is happening all the time. Um, I guess more on that in the next video, but um, similar to math, like the domain is like the set of all inputs that this function can take on. And so square can the domain is kind of like all real numbers. Um, and so x is a number, any number. And the range is the set of all values, like output values that the function can return. So it returns a non-negative real number, like that's the range of this square function. Um, and yeah, the behavior of the function is kind of what the function does. Like, so this just returns the square of x. Yeah. So just examples of how we would describe other functions. Like, okay, we spend a lot of time on like just scoring a number, but so we have like a function greeting which takes in has three parameters, like f name, like first name, which is a string, l name, which is last name, a string, age, which is an integer, and right here we kind of have like an arrow which just signifies what the return value of this function is supposed to be, which is a string. And so this is our doc string which describes the behavior of like the function greeting. And so this is a function that returns a greeting with the user's information in a string format. And so we're setting the variable string to like this f string. Hello, my name is, and like what happens when we call the function is kind of like f name gets passed into the string, as well as like last name. And I am 8 years old, so the variable age gets passed into the string. And we return like this kind of greeting right here. I guess I don't know if I can really copy and paste if it really works like that, but let me try. Oh, that's kind of cool. Yeah. Print greeting. So we're gonna use an example with myself. I'm 19. Getting pretty old. So when we run Python, we're gonna it goes like sequentially, like in order, evaluates. So this is like our kind of our script. And so it sees that we have a function greeting and it adds like greeting to the global frame. So greeting is like bound to this function object called greeting with three parameters, and it's in the global frame. And so now we're calling the function print with like the operands, which is like another kind of function call with greeting, which takes in like the parameters, like my name, my first name, my last name, and my age. And so we're gonna call it now. And these are the parameters right here that, so we open up another like frame one, where we call the function greeting, and the parent of greeting, like greeting is defined in the global frame. So that's what this means. And yeah, so yeah, the parameters are passed in, and now we're gonna evaluate string. And what string is gonna do is it's gonna kind of basically input like all my like this f string kind of like inputs like the variables right here into the string. And so now this is what string is set to. This is essentially the greeting that we're going to return in the next line. And that's what gets printed out into the console right here. Yeah. So it's just essentially it's just good practice to have like good documentation and just knowing what inputs type, like what variables, what type, what data type your variables are supposed to represent. But like let's say we pass in I guess we could do this like another like just short um okay, we said that first name needs to be a string, but Python is not that strict. Java is a bit more strict, but let's say we pass in like 0, 4, and my name right here or something weird like that. Um, so okay, we're gonna call the function greeting with the parameters. So first name is set to 0 and integer 0 when we said it's supposed to be a string. Last name is also like a weird integer, and age is not an integer, age is a string. And so this will perform all well and like cool. And this is what happens. And not yeah, like we yeah, it's gonna pass and it's gonna run, but that's not the intended result. But the point is like that it's just good to know like what data types they're supposed to be, but it's not going to stop you from running it a different way. But don't do that, please. Don't be weird. But so reciprocal, oh yeah, by the way, the like just saying what data type a variable is supposed to be in like a function is optional. um yeah, like this one I didn't do it, but so reciprocal, the behavior of the function is like it returns the reciprocal of a real number n. um so the thing is that 0, like we can't take the reciprocal of 0, um because like that would essentially mean that we would be doing 1 divided by 0, which is actually undefined in math. And so that would I mean, I can show you that 1 divided by 0 is a 0 division error. You can't divide by 0. Like any number divided by 0 is a 0 division error. So Python doesn't like that. Math doesn't like that. Um, so the domain would be all real numbers except for 0. The range would be also be all real numbers except for 0, because there's like no way to like kind of return 0 in that case. Um, I guess I don't know, is it really all real numbers, or I think it would be the range would be anything between 0 and 1, or not including 0, including 1. Actually, wait. Um, actually forget what I said, because n can be anything. So yeah, forget what I said. Uh, sorry, I'm screwing around. Is it recording? Okay, so this is like a lot of like jargon, but uh, hmm, um, okay. I'll just start with this slide because it kind of makes more sense. But so in Python, what we do a lot is we have like ifs, like we have conditions. Like we don't want to always run this like body of the function. Um, like sometimes we want to have conditions like run this line of code if this condition is true, or like run this line of code if the other condition was false, but this condition is true. So that's where if statements kind of come into play. And so this example right here is that we're creating this function called absolute value, and we want to return the absolute value of x. And absolute value is just like the distance a number is from 0. Like it's like a positive number essentially. And so like we're saying if x is less than 0, then we're going to return negative x. And so okay, we have hmm, um So there's like one statement. I guess the headers are like this part, like if x is less than 0, else if x equals 0, and else. So these are the headers. Sweet, I don't know, but yeah, people don't really use like this vocabulary, but yeah. Um, so first what we do, like sequentially, we evaluate the expression of the header if x is less than 0. Let's say we're doing absolute value of 4, right? And so we're going to evaluate x is less than 0, which returns us a Boolean, either true or false. If the condition is false, we're not going to go into the body of the function at all. We're going to skip that. And so absolute value of 4, like okay, x is not less than 4, is not like 4 is actually greater than 0. And so we're going to go on to the elif. Like elif is kind of like, it's basically saying it's else if, like else if, like okay, if this condition is false, we go on to the elif, and we elif is like check this condition. And okay, is 4 equal to 0? Well, no, it's not. So we're not gonna run the body of this, of like this header, and we're gonna go on to the else condition. And else there's no condition to check actually for else. It's just like assuming these two failed, like we know this has to be it, and so we're just going to return x. And so this body of the function is going to run, and we're going to return 4. um so elif and else are actually optional. Like in the other example I just did, we only use an if statement, but we can have if and else. We can have if, elif, and else. We can have if and elif only. It just depends on what you're kind of coding up. Um, yeah. Uh, yeah, I think that's, I could run a couple of like just examples of like absolute value a bit more, just to show how it kind of runs, and so you guys can see. Okay, so we create the function absolute value, which is like in our global frame, points to the function object absolute value with input. Okay, so now we create a local frame for our first function called to absolute value, where input is 4. And now we go on to the if statement. Is x less than 0? Well, no, it's not. So we skip the body, and then we go to the elif. Um, and this is also false, and then we just return 4, and that's what's printed out. Absolute value -4. We created like another frame 2 in our it's our local frame, where the intrinsic like name of the function is absolute value, where it's defined in our global frame, and the input is -4, and we're saying we're in this condition, is -4 less than 0? Well, yeah, it is. So we run the body of the function, and we return the negative of -4, which is 4. And then we don't run anything else. Whenever we return something, that ends the program essentially, and nothing else happens, right? So like let's say we want to let's say we want to assign like y to x times x. I don't know why, but um like this is like, okay, going back to this example, we will return 4, right? And that's it. This line of code never gets executed. So like basically whenever we return something, like that's it. Nothing else gets run. Nothing else is checked. Um, yeah, so now frame 3, we're calling absolute value with input 0. And so we're saying if x is less than 0, well, x is not less than 0. So we're going to go into the elif, which is true. And so we're gonna we're gonna run the body of this like kind of clause, and we're gonna return 0. And that's what's kind of printed out right here. Yeah. Okay, so now we're gonna do another example. This is hmm. Yeah, this is the official CS61A website. Um, so what the problem is so we have a person called Alfonso. He's a weird guy, and he's weird because he only wants to wear a jacket if the temperature is below 60 degrees or if the weather is like raining currently. And so so temperature is an integer. I'm just gonna put this for myself, and raining is a boolean. And so these are kind of like test cases. So like for example, a call to weather's jacket with if like with if is I guess this is just like the name of the function. And we're saying the temperature is 90 degrees and it's not currently raining. And that Alfonso's not going to wear a jacket in this case because it's not raining. The temperature is like pretty hot. So no jacket, right? But okay, the temperature is less than 60 degrees. And okay, it's not raining. That's fine. But since the temperature is less than 60 degrees, according to this kind of condition that we have here, Alfonso's gonna wear a jacket, so we're gonna return true. And all right, the temperature is 100 degrees, but it's raining, right? I mean, I know that's kind of insane, but we're gonna wear a jacket. And so the way we do this is we're gonna use like kind of an or, kind of the keyword or. And so we're saying if the temperature is less than 60 or like raining equals true, this actually isn't needed. We can just say or raining. Then we're gonna return true. I mean, I could just put this here just to like kind of be more precise. Else, like if this condition isn't like satisfied, then return false. And we can actually run this in the CS61A interpreter. We click on this, we run the doc test, and we see that everything passed. So our function is probably correct. I mean, not always correct. Like if our test case is passed, doesn't mean we're always right, but we are right here. And to do this in one line without the if statements is that we can just say return temp is less than 60 or raining. And yeah. Oh wow, let's save my work from when I took this class. Uh oh, this one uses a while loop. Okay, these are a bit more advanced. I was thinking of going over. Okay, so iteration. So a while loop is kind of like a series of statements that we're gonna like run like a body as long as the condition is true. So we have like a starting point, and we're gonna keep running the same like code over and over until like we have a condition that's false. Um, and then when the condition is false, we exit like the body of the while loop. And so this is kind of like how it looks like syntactically or just like the grammar wise. So we have like while this condition is true, we're gonna perform the body of the while loop. And if it's false, we're gonna exit out immediately. The else block nobody really uses. I don't know what that's about, but let's look at a demo of what this is. Oh, okay, this is a bit more advanced, but this is, I think this was like in an interview question, I'm not sure, but so we have a function fizzbuzz, and okay, I really don't know why I made this example. Give me 1 second, I'm gonna find a different example. Yeah, I'm just gonna cook something up on the spot. So let's say we're doing like a number guessing game, and we we want to let's say these are like, okay, this is like super simplified and doesn't have every little detail, but we're gonna make a number guessing game, and inside of the number guessing game there's gonna be some kind of while loop, and we we only want the person to have 10 tries before like they lost, like before like you know you lose, like you can't we don't want them guessing forever. But yeah, we're gonna set tries to 0. Like this person hasn't I guess maybe we can say guesses, like how many guesses has this person made so far? It's 0. And I guess we can make a function like def guess and integer n. And we can say guesses is like a um, guesses is a global kind of variable. It exists in our global frame. And then we could I guess I'm getting a bit more advanced into this, but we can import random. Import random allows us to kind of get like a random integer. So we're gonna say like the actual number that we want to guess is equal to a random integer between 1 and 100. And so now what we're gonna do is create a function called guess. And while guesses is less than 10, we can keep guessing. Or actually, wait. Uh, 1 second. All right, forget about the function thing. But I think I found a good like I have a good example of like when you would want to use a while loop. So I guess in my Discord bot, I do have like a number guessing game that's like just a simple number guessing game, not that fancy. But we're gonna import random. We're gonna set like the number of guesses that this user has made to 0. Like we haven't made any guesses, and now we're gonna like the computer is gonna just generate a random number between 1 and 100, which is the answer to guess. And so while guesses is less than 10, actually, ooh, I want to, okay. Um, hmm, else, okay, so we're guess equals input. What that does is like the user is going to input the number they want to guess. And if the guess is equal to the number, then we want to say you won, basically, and that's it, right? Else, okay, and okay, so we actually need two conditions. It's like we want this while loop to stop if the guess is not equal to number. If the guess equals number, then that means the game is over. But else if guess like the guess that we've just made is greater than the actual number, then we should probably just tell the user lower, like just like guess lower. And maybe you have or we can make this a, like an F string. You have 10 minus or 10 minus guess guesses tries remaining essentially. And else like if guess is greater than number, actually we can do this. Elif we can do elif guess is greater than number, and then we can say else um, prints f higher you have 10 minus guesses tries remaining. I think that works. Okay, so these are just the conditions of like what happens when you guess the number. Just informing the user to guess lower or higher based on what the guess is and what the number is. This and we're setting guesses to or we can say you won in guesses tries, just to tell the user how many times it took for them to guess the number. And after every while loop, we're going to increment. Actually, we should probably do this right on the top because guesses is like set to 0, but we're going to increment the number of guesses taken like every time that we perform the body of the while loop. So essentially, I could just run this honestly. So import random, the number of guesses that I've just made right now is 0, and the okay, that's okay. 50 is I don't want to work with 50. Um, is this really random or what? Okay, that is I don't know about this. How am I getting? Okay, well, PyTutor is being weird. Um, is it raining? It's getting kind of spooky in this lab, but that's because I'm here at like 11 o'clock. My God. Or whatever. Um, okay, so number is 50. I don't know why. It doesn't look like it's really random, but I think PyTutor is kind of weird. We're just gonna work with that. We're just gonna set guess to -1. Like it's just a placeholder because just so the while loop condition kind of holds. Um, so we're gonna set the number of guesses that we taken equal to like we're gonna increment it by 1. And now, all right, we're gonna try to guess the number. And I'm gonna guess 25. We're gonna submit that. Uh, hmm. Oh, okay. So we actually make to convert this to an integer. Okay, so now we're trying to see like does 25 equal the number that we guessed? No, it isn't. So we're gonna go into the elif. And elif is this guess 25 greater than the number? No. So we're gonna go into the else, and it's saying we gotta go guess higher, and we have 9 tries remaining, and we're gonna keep going. And I'm gonna guess 55, right? And so it's okay. We need to guess lower, man. We have 8 tries remaining, okay? And now I'm just gonna guess the number. Like we're not gonna keep going. Um, and so we finally guessed the number in 3 tries. And yeah, that's a simple kind of while loop and like an example of why we would use a while loop for this kind of like number guessing, simple number guessing game. Yeah, this other demo is like a bit more extreme or not like that. Can't be applied directly. I'll do this. Largest factor. So, hmm, let me just pause the video. Yeah. So if you guys want to do this, you can pause the video and try it. But I'm just gonna kind of walk through how I would do it. Actually, I'm not gonna use this website. I'm gonna use code.cs621a.org. Uh, so create a new file. Okay, so now we're trying to create a function. So n has to be greater than 1, and I have to just put in a search statement. Like basically if n is not like n is equal to like something like less than 1 or equal to 1, then this would raise an assertion error and the code wouldn't run like that. And everything else below the assertion statement wouldn't run. Um, but okay, so essentially we're gonna need a while loop for this. We want to return the largest factor of n that is smaller than n. So let's say we have the input 15, and the factors of 15 are like 1, 3, and 5. Like 5 times 3 is 15. One is a factor of everything. But I guess the takeaway is like the fact like if we have a prime number like 13, then like the factors of 13 are just like of a prime number are just the prime number and 1. And so, sorry. Um, so we had to return the largest factor. Um, so we're gonna start with I guess the largest is equal to n minus 1. And that's because we don't want to like we're gonna while loop through to find the largest factor, but we don't want to like for 15, like we're not gonna say 15. We're gonna start and see is 14 a factor of 15. And so we're gonna start our while loop with while I guess we can say while n is not equal to 1. And wait, sorry, I'm actually just thinking about this right now. No, we need another variable. Or no, we don't. Okay. So the largest is the largest factor, right? And so the stopping point is like the starting point that we're going to check is the number minus one. So like we're going to start with 14 and we're going to see if is 14 a factor of 15, right? And we're going to keep going down the list. And the worst case scenario is like if a number is prime. If a number is prime, then we return largest, or we will just return, you can just say return one. But I mean, in this case, the while loop, we're gonna keep decrementing largest by one, essentially, like every time. But I guess until we find a factor. And a factor, how do we find a factor? Well, let's open up the Python interpreter and okay, is 14 a factor, right? And so when we do 15 divided by 14, we see 15 divided by 14 doesn't evenly divide, right? We left with some weird funky decimal. And 15 divided by 13, 15 divided by 12. And we're going to keep going down the list until we reach 15 divided by 5, which actually evenly divides. There is no remainder. And so a cool thing in Python is like the modulo, or cool thing in math is like modular arithmetic. And so, okay, an example, 15 modulo 14 gives us one. And what is one? What is one? Well, one is the remainder of when you divide 15 and 14. So 15 goes into 14 one time, and we're left with the remainder one. And modulo is essentially like when you divide the number like a and b, the remainder of a and b is what modulo actually returns. So 15 modulo 13 gives us a remainder two because 13 goes into 15 once, but we're left with a remainder of two. And so 15 modulo 5 gives us a remainder of 3 because 5 goes into 15 three times evenly and there's no remainder. And so that's why it's equal to 0. And so we know that a factor of a number n, we can say that if n modulo the largest is equal to 0, then we found the largest factor right there. In terms of like we're in this while loop, we're working from the n minus 1 to 1, like we're working backwards kind of thing. We're not going to start with 1 because I guess the runtime would in the best case scenario would be better, and the worst case scenario the number is prime. Yeah, if the number is prime, then we would have to go all the way down until we reach that number. But when we reach this if statement, we immediately know this has to be the largest factor because we're working backwards. So we can automatically return largest, which is the largest factor in this case. Otherwise, we would just keep decrementing largest by 1 until we reach 1, or until we find a number that evenly divides n, like, and kind of gives us the remainder 0. So let's try this. I think this works. Yeah. But yeah, I could do 2 examples of this. So let me just put 5 because it's gonna save us some time. So we have the function largest factor with I guess this is a frame 1, and we're calling with input 15, and we're gonna set largest to 14, and we're gonna start our while loop, and we're gonna keep going until largest is not equal to 1, or if we find our largest factor. And so n modulo largest, so 15 modulo 14 is equal to 1. So we're gonna skip the body and we're gonna go into our the rest of the skip the body of the if statement. We're gonna go to the rest of, like, we're gonna decrement. We're in this code, line 15, we're gonna decrement largest by 1, and now largest is 13. We're gonna check 15 modulo 13, is that equal to 0? Like this 15 even divide 13. No. So keep going, same process until we hit 5. And oh yeah, That's it skipped a whole bunch of steps right here, but um hmm, I don't know if it's really it could actually be raining. Oh my God. Dude, if it's raining, I'm not walking home. It's 11:10 p.m. right now. It probably is right now. Okay, that's fine. But yeah, we see that 15 modulo 5 equals 0, right? And so that's our largest factor, and we return 5. And largest factor of 5, so 5 is a prime number. So this is the worst case scenario where like we go through the whole while loop and we don't see anything like is evenly divisible. So we go through all the while loop until like largest is equal to 1, which is like since like uh, this condition has to be true for the while loop to like keep going. But now we've reached the point where largest is equal to 1. So this condition is false. And now we exit out of the while loop and we perform the rest of the code, which is to return largest. And we know we have to return largest because, well, that's like, we basically know we reached the bottom and that this is a prime number. So therefore the largest factor is 1. Okay. I don't know what this is, but let's try it. Oh, I didn't know I had this here. Okay. Okay, so for loop is another type of loop, but usually when we use for loops, we iterate over a sequence, like a list, a tuple, a dictionary. Um, so like the condition, actually, there's not actually a condition. You would just keep going through the sequence until you reach the last item. Um, yeah. So this is how a for loop kind of looks like. Um, so for I in range 5, so we iterate through like actually this kind of creates so I is like a variable, and every time we go through this loop, so in Python everything is kind of like zero index. So what happens is like range 5, like 5 is not inclusive. So um, we would start with the value 0 and we would keep iterating through, and the last so I would be set to 0 and then we set to 1. Like I would be set to 0, do all this stuff in the body, but then now I is gonna be set to 1, do all this stuff in the body, and keep going until we reach 4, and now I is equal to 4, do the whole body, and that's it. That's kind of how the for loop works for that range part. I mean, range, so range of 5, what is range of 5, right? uh well, it's kind of, I would think of it as a list where you would iterate through the elements and here, like 0 through 4. And so every time, so I guess an example, like for I in range 5, print I. And so it like basically like first I is set to 0, then 1, 2, 3, 4, right? And so it would perform the body like 5 times total. But yeah, 0 indexed and not inclusive for the number that's inputted into the range. The L-Spock, I don't know what that's like junk. Nobody uses that like that. Um, but let's see what this is. Oh, this is just fancy stuff. Uh, okay, let's say we have like a bunch of Pokemon, like Charmander, Pikachu, Squirtle, what's a good Pokemon? Um, hmm, Dragonite, Mewtwo. And so this is a list of Pokemon. And what we can do is we can like list. So we can say the name can kind of be, it's just like a variable. Like it could be anything right here, like the for name and expression. I think that's expression. So expression is like a sequence or like an iterable like value. And so we would for Pokemon and Pokemon lists. So we're going to iterate through all the values in our Pokemon list, and we're going to print what the Pokemon is. That's just our simple script. And okay, so we have our Pokemon list right here. And now Pokemon is kind of like so it just goes in order. And so first we're gonna set Pokemon to the zeroth element, and they're gonna print it. And now we're gonna set Pokemon to the first element, Pikachu. We're gonna print it, and it goes in order like that. Yeah. So it iterates through the whole list, and it changes the variable right here, the name, to the next value. That's like the for loop, what the for loop kind of does right here. I actually already did this earlier. The number guessing game. That was kind of my example I did earlier. Um, yeah. Well, yeah, I already did this. So containers, so yeah, just more on like formally defining what a list is. So a list is a data structure that's mutable or changeable. So right here we have like teachers. This is actually my senior year schedule. I had a 0 period and I didn't have a 6 period. So I guess the indices are actually what matches up my schedule. So Lipping is like my 0th period teacher, Kaler first period, Lockie 5th period teacher. And so we can I guess I can do this live. Or actually, well, I can't. I don't remember how to spell these teachers' names. I'm not gonna be able to do it on the spot. But so the way we can access like an element inside of our list is we can use like the square bracket where we say the integer, which is the index of the element that we want to access and like kind of return. And so teachers of 2, this is the 0th element, first element, and 0 element. So teachers of 2 is going to return us the element located at index 2 of our list, which is Burrows. And there's a lot of like useful functions for like when you're working with lists or like these kinds of data structures. And sorted of teachers, like sorted is like a built-in function that sorts the entire list in alphabetical order or lexicographic order. We could like list can have kind of any kind of data type in there. Like we can have a list of functions. I mean, we're not really gonna do that, but actually add, I think you have to import. Yeah, we can have a list of functions and then we can apply like the function, like this is the function min, like we're retrieving the function min with and we're calling it with the parameters 2 and 3. This was like this kind of thing was like on one of my exams. It was kind of ridiculous. We can have like a list doesn't have to have all the same elements. We can have a string as the first, like same elements in terms of like data types. We can have like this kind of list now. And so we have like a string, we have an integer, and we have a function. But usually we don't do something like that. That's only if you're like CS61A and you're like a crazy guy. And so len, like the function len, like returns the length of the list. So the length of teachers is 6. So I had 6 teachers, 6 classes in my senior year. And we can actually list are immutable, so we can change what the element 2 is by using teachers 2, and we're going to set that equal to Cooper. I didn't have Cooper, but I had a Cooper in my junior year. And now, so goodbye Burrows. I have Cooper now, and so we can print our teachers again. And this is my new schedule. So yeah, lists are ordered. If new items are added to a list, the item will be added to the end of the list. And how do we add something? Like we created a list, right? And we can, I guess there's 2 ways to do it. So when we want to add something, there's 2 ways to do it. So I'm going to set list to list plus like addition plus, what should I do? I can just say, I'm going to add an empty list, or no, I can actually do this. I'm just going to set it to a list of like the first couple even numbers. And so now my list, like I have 4 elements. The length of my list right here is 4. And this is my list again. The 0th item is like a string. The first is a integer. Second's like a function. And the third is a list. We can have a list inside of a list. So it can kind of get crazy, but we're not ever going to do something like this. But oh yeah, the other way to add something is the appends, which is like We can append, like add something to the end of the list. We can just append the number 0. And the number 0 is right here now at the end of the list. Oh yeah, we can also do insert. Like, let's say we want to insert something. Actually, I don't even remember. So the parameters of insert are index and the object we want to insert. This is our list, and let's say at index 1, like right here, I want the value 5 to be, or the value maybe Pikachu to be right here, and then everything else gets moved over to the right. And using the insert, that's kind of what happens right here. So lists are immutable. Lists can allow duplicate items. Like I can do list.insert one Pikachu again. And now we have Pikachu right here and Pikachu right here. So we can have duplicate values. There's no problem with that. So items of a list can be any data type. Like this is strings, integers, booleans. We can just mix and match like what I just did. So why do we use lists? So lists allow the programmer to keep like data that kind of belongs together, condense code, perform functions on a collection of values. So I do have like what do I have? I have like a Pokemon like scramble kind of like game. So I have like a file. So I guess what you can do is have like a, okay, I guess maybe I shouldn't go into that. Let me try to think of what I could use a list for. So I can have a list of like so let's say I'm playing the guessing game in my Discord bot, and hmm, hmm, hmm. Give me 1 second. So actually I just thought of something like why would we use a list? One example is like there are like some Discord bots where like if a person is like away from keyboard, like the bot can kind of store that. And if like okay, that person's away from their keyboard and somebody tries to like mention or ping that person that's away from keyboard, well, okay, when a person's away like AFK, and the bot can kind of add them to a list. And okay, so every time a person is pinged, the bot checks in this list, is this person's ID inside of this list? If this person's ID is inside of like the AFK list, then the user that pings that try to ping that person is going to be informed that they are AFK. And that's one way we can use lists, and I actually do that on my bot. Um, so that would be like a list of Discord IDs that are like AFK. I guess in this example, oh, this is just a for loop. Like we can like use for loops and lists. And so I have teachers, but now I want to like create like a new list of cool teachers, right? And so I'm gonna for loop through all the current teachers for elements and teachers. And we're saying if the string O is in like the teacher's name, we're gonna add them to the cool teachers list. And so sorry to Mr. Lipping and to Mr. Frejo, like they don't have the letter O in their name. So sorry you guys aren't cool. So these are random like there's a lot of stuff you can do with like um with lists. So this is like digit lists, and the length of the list digit list is 4, and the third element is 2, or wait, 0, 1, 2. Oh, sorry, yeah, the third element is 8, and we're not really gonna do this, but you can kind of multiply a list, and it will just return the list like that many times. Like concatenate like the list. Um, yeah, this is a bit crazy. But nested lists, we can have like a list of lists, and we would do something like this when we is this recording? Yeah, it is. When we're making like a 2D board game, like tic-tac-toe was kind of like a list of lists, like yeah. And what else? There's just like a lot of board games like Connect Four. It could be like a list of lists. So that's really important. And to access I guess to access, how do we get the number to, like, if we do like we get element one of like this list of lists, it will return us a lit like the first element of the list, right? Which is a list like 30 comma 40. But let's say we want the 0th element of this list, right? Of the first list, then we would say pairs 1 of 0, which is like this value 30. So these are expressions right here. Like they're not fully like evaluated, but you run this into Python and they will be evaluated. And like this would be a digit, like a list of numbers where this is 1, was 8, 2, 2 times 2 is 4, yeah, 8. Get item, nobody really uses that. I think this is the same as, okay, these two are the same, but get item is like kind of too formal. Just use square brackets. That's what everybody does. This is kind of insane, so I'm not gonna go over that. So yeah, just like examples of like lists, like we have can have a list of fruits. The count method of a list is like we're just we're like it's basically like for looping through the list and checking how many times does this element exist in our list. So there's 2 occurrences of apple in our list. So that's what that is. And tangerine doesn't exist in our list. The index of banana. So there's actually 2 instances of banana in our list, but index is we're gonna return like the number, like occurrence where the first occurrence of like this element in our list. So the first occurrence of banana is 3. It doesn't care about the next occurrence. I guess this one is okay. I actually didn't know this part. You can find the next instance using I guess there's a second optional parameter where like you start at this position, you start your search at this position. But I believe if it's not in the list, then it will return -1. Like actually no, or yeah, is that true? Like okay, so we have a list, and we want to find the index of what string, like what peak, what oh, it's not in the list, then find the index of 7. Okay, actually, it didn't return -1. Okay, whatever. So reversing a list, so it kind of just like it would start with, but like banana is the last element, but now it's the first element. Apple is the second to last, and yeah, so on. So reverses the list, and now append adds like this new element to the end of the list, and that's what happens here. Sort like sorts the list alphabetically or like lexicographically, and pop returns and removes the last element of the list. So pair is no longer in the list. Containers, I don't know what this, okay. So there's built-in operators for checking whether an element is like inside of our list. So we have digits. We define digits to be like a list right here. And we can say, all right, is 1 inside of our list of digits? So we can just say 1 in digits, and it returns a Boolean true or false. Same for 8 in digits. We can say is 5 not in digits? Okay, these 2 are the same. It's just like they're just grammatically different, but they're saying the same logic. So lastly, dictionaries are pretty important also in my Discord bot. And so this data structure is like a key value kind of pairing. So this kind of thing that we have here is like the key is a person's name and the value is their age. And so dictionaries are ordered, they're immutable, except the keys cannot be duplicated. We can look at this demo. I'm not too sure, remember what this is. So we have like a dictionary with like a Pokemon name and their Pokedex number. So we start out with just 2 species, but we can just add something to the dictionary. So like Pokemon is a dictionary. And now to add like something new, this is the key, like we square bracket the key of what we want to add, and this is the value. And so we're going to add Magikarp to our dictionary with the key, like the key is a Magikarp is, and the value is 129. And we can print the dictionary, the Okay, we can print Pokemon chart. So we say Pokemon, we're gonna look at like we're dealing with the Pokemon dictionary, and we want to know what the like we're inputting the key, like we want like we're saying what we have the key Charmander that we're inputting into our dictionary, and it's gonna output the value associated with that, which is the Pokedex number 4, and that's what it prints out. And print Pokemon prints the whole dictionary. And we can delete something from a dictionary using the like del, which is short for delete. And so we're gonna delete the entry like Pikachu, and it's gone now. Now there's like, similar to what we've just did, there's like we can check if a key exists in our dictionary. So print Pikachu and Pokemon, and that's false. Pikachu is not in our dictionary. Now we can check if a value exists in our dictionary, like is 4 in like our Pokemon dot values. Like dot values returns us like a kind of like a list of values. Like it would return like a list with 4 and 129. So true. And now we can add like Ekans, like the snake Pokemon, into our dictionary, print out the new Pokemon. And we can also print the list. Like when we say print list of Pokemon, it prints the keys of the like of the our dictionary, but not the values. Um, and how do we iterate through the both the keys and the values at the same time? Well, we can say like KV is like kind of short for short for key and value, and like Pokemon that items is we're kind of returning us like an iterable object with like keys and values. So for KV and Pokemon that items, like Pokemon that items is like this is the first item and this is the second item, and we're assigning the first item to the variable K and the second item to the variable V. And it's like K and V is reassigned after like every time we finish the body of this like this one iteration, then we would go to the next, like then K and V we reassign to this, and so on. And so it would print out like, yeah, prints Charmander and Magikarp Ekans like in the order of the dictionary. And yeah, it's raining hard over here. Yeah, these are more examples. So we have an empty dictionary. This is just the empty dictionary. It's also a false value. And this is a dictionary where like the key is like an integer and the value is I guess a string. Yeah, this is just I just found this online. I don't not the best example. I like my Pokemon example better, honestly. But yeah, so dictionaries can have whoa, what is this? Uh okay. So we have a key, which is name, and the value, which is the person's name. We can also have a key, like it can have different data types. Like the key can be a string, an integer. Key can be like literally whatever. I believe. Yeah, I think there was like a certain restriction. Because of hashing. I don't remember what it was. Oh yeah, wait. Okay. There is a restriction. Um, D equals empty dictionary. And now we're gonna try to put a list. Okay, so a list cannot be hashed. So we cannot have a list as like a key because it's kind of beyond the scope of what we need to know. But oh yeah, because lists are changeable. And since the list is changeable, when you change the list, the dictionary is not going to know where to kind of look up. It's kind of a weird thing. You can kind of learn that in data structures, but a value that is like going to be changed, like a list is like mutable. Um, you can't have that as a key. But you can have it as a value right here, because when you look up a key, like you have to look up a key, and it's gonna return the value. But yeah, forget it. But just know that you can't have a list as a key because it the list is mutable. Tuple, I think a tuple is basically like kind of like a list like this, like with brackets or with sorry, parentheses, but they're on like not when you create a tuple, you can't change like the values So tuples are not mutable. I don't know what this is. Oh, D. Okay, so yeah, we can add a tuple, but we can't add a list. Let me see if I can add a dictionary. Okay, so yeah, dictionaries like that. Yeah, you can't add dictionary like a dictionary to a dictionary. But I think you can add like as a key, but the as a value you can. Oh, this is just another way to like create a new dictionary. Um, yeah, that's cool. Um, okay, so we created a dictionary with the person's name and their age, like as a key and a value kind of lookup. And so we can change the person's age right here by like saying like, okay, get this dictionary and now this key. We want to change the value of like that's associated with this key to this like to this number 27. And we print it out and this is what's going to show up now. Um, yeah, I don't know if it actually really shows up on this order. I would think it would show up the other way, but that's all right. And we can add an item similarly by just using the key. Like we're gonna add the key and we're gonna have this as the value. And yeah. Um, so we're gonna do this short. Oh, I put the answer there, but so we're gonna create a function called add experience, which takes in two arguments, user and XP, which updates the global dictionary called users. If the user is not in users, add the user to users with XP experience points. If a negative XP value is given, then throw an assertion error. So you guys can try this on your own, and then you can kind of look back at the solution, which I'm going to do right now. So we have a function called add experience, which takes into arguments, user and XP, right? So user is a string and XP is like an integer. And what this function does is this updates the global dictionary called users. Um, yeah, I'm not going to be that descriptive. Um, actually, let me do this in the other website. Or yeah, I'll do it in the other website. Um, I'm gonna have a couple of doc tests as to what is supposed to be happening. It's good. It's like good practice to like make tests before you write the code sometimes, which is what I'm gonna do. So yeah, in like Discord, I mean I have a database, so it's not the same thing, but um but this is just a simplified version of how like an experience system would work. I mean, this is kind of valid too, but it's not like persistent. Like I have a database because it's like persistence. But like when you use like stop the bot from running, like this dictionary right here, I think I said it's gonna be called users. Um, like when you stop the code from running, like you lose like this like binding of like the what was stored inside of the dictionary. So that's why we kind of use a database. So like things stay persistent and we still have the data even if the bot is not running anymore. I'm gonna say like user is like completely empty, right? And with this in mind, like right, the users is an empty dictionary, and that's gonna be true. And now we're gonna add like we're gonna give Mehul, which is me, like 5 experience points, right? And so now we're gonna check that we're gonna look it up. Do I have 5 experience points essentially? And this should evaluate to true. So add experience, it's not actually gonna return something. So this is one of the instances where like we're not actually gonna return anything from a function. We're just gonna update something outside of like the function. Um, so now I'm gonna add, actually, I'm gonna say like Bob in users, right? And this should return false. And now I'm gonna add experience Bob. I'm gonna give him, I'm gonna give him 2 points, right? And so now I'm gonna say users Bob equals 2, right? And that should return true. And now I'm gonna add XP, or I'm gonna say like Mehul and users, right? And that should say true. I'm still should still be in there. And I'm gonna update my experience points. And I'm gonna or wait, I need to create the call. And I'm gonna give myself I'm gonna give myself 100. I don't care. What do you guys say? Well, I'm giving myself 100 experience points. And now what I should have a total of 105 experience points. And that should return true, right? And I think that's comprehensive enough. If everything right here passes, then I think that this um, program should be working correctly. Um, oh yeah, we could just do Bob and users again. It's not gonna, this time it should say true. Like nothing's gonna change about that. So first, like, um, okay, so I guess let's say like we have users, right? And we can add something to our list by just saying what the key and the value is, right? And so now I'm in the, here I am, like, okay. So that's like the first way we could do this, like, so here's the naive approach. Users, we can just say users, like user is the username. I could just call this username if that's like easier to understand. And we can just set that to experience points, right? That's the naive approach. This isn't gonna actually work, right? And so we passed a couple of doc tests, but we see that I actually don't have 105 experience points. So I wonder how much I actually do have. So um, 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 okay, so it says I only had 100 experience points right here during this like my doc test right here. And this line, when I looked up in the dictionary the key Mehul and I tried to get the value, it gave me 100. Like this script gave me 100 points, right? So I don't know what happened with the other 5, right? And so this is not the correct approach essentially, because all we're doing is we're just overriding every time we call this function. We're overriding like we're not the experience points is like not being updated. It's just assigning this experience, like it's assigning the experience points to me, but not like adding it up essentially. So the way we're going to do this is we're going to use an if statement. So if username and users, right, then that means like I already exist in the dictionary, and so I'm going to update the experience points that I do have. And we can say, so this is gonna like this part is gonna like return like an integer of how many experience points I currently have. And like this part is gonna assign like the new value is gonna be what the old value was plus the number of experience points I'm gaining right now. Otherwise, if I'm not like, if this person is not in the like my database of experience points, like this is probably the first time they're using my bot or something like that, like saying like that this is add experience points is like a command for my Discord bot, then we're going to do what we just did, and we're just going to give them like they're new to the database, so they just get that many experience points awarded, and this should pass. Yeah. So I don't know if I really want to walk through. I'll walk through a little bit of it. Um, yeah, I guess it's kind of good to visualize this. So yeah, I'll show like what is kind of happening in PyTutor. But yeah, this doesn't return anything. It just updates the use the like the global dictionary. Okay, I think that's good enough. So we define users, which is empty dictionary, which is going to store everything like all my database user and experience points. We define the function add experience, and now we're calling it with the parameters Mehul and 5, right? And so we're saying, all right, if Mehul is in the dictionary, then perform the body. When I'm not in the dictionary, the dictionary is empty. So we're gonna perform the else, which is we're adding me to the dictionary with having the key is like my name, the value is the number of experience points, right? And now I'm in the dictionary. And return value is none. Like nothing happens. Like nothing's returned, but like the dictionary is being updated essentially. And that's yeah, we're done with the first one. And now we're checking if is Bob in users. Well, no, Bob, like the key, Bob doesn't exist in our dictionary yet. But now we're gonna add him. And this is just like knowing like the methods of a dictionary. But so we're gonna add Bob. Like, okay, is Bob in our dictionary? No. So we're gonna add him with 2 experience points, right? And we're just checking, does like the value, like we're gonna look up what Bob is. Is that equal to? Well, yeah, it does. So now we're on am I in users? It's gonna be true. And now we're gonna add 100 points. I'm awesome. I get 100 points. I win the jackpot. And okay, so we're gonna pass in like the parameters, and we're gonna check, am I in the dictionary? Like my username at who is it in users? Well, yeah, it's right here. And so now we're gonna update right here. The value of me right here is gonna be equal to what the old value was plus the number of experience points that that's being added. And so now I have 105 points. So yeah, that's this kind of like little pattern is kind of common in like dictionaries, I feel like. But yeah, that's actually the end of let me check the answer. I think the answer says the same thing, maybe with like different variables. Oh, I did a little bit different, like I did different tests right here. That's kind of cool. Oh yeah, I forgot the assertion. So we don't want to like give negative points to somebody. Um, so yeah, we just want to assert that the experience points is like positive. Like we don't want no negative points, essentially. Um, yeah, and this is the same. Yeah. All right. Well, if you guys have any questions, I mean, I know this is like a lot of stuff happening in this video, but yeah, I mean, um, there's a lot of resources to, I went through a lot, but it's all right. Your Discord bot doesn't have to be that advanced. Just do what you're comfortable with. Um, but if you want to like learn something more in detail, watch like YouTube videos. You can go through GitHub, but it honestly takes practice. Like I know I kind of sped through a lot of this, but I do have like experience, but uh yeah, it just takes a lot of hours. But yeah, definitely practice outside if you're interested. But yeah, you can also just ask Samim. I'm sure he's like really experienced. And yeah, thank you guys for watching.